Hello, today let's talk about polynomial functions. So what is a polynomial function? For polynomial functions, the powers of your x's are integers. So the value for n here has to be an integer. Otherwise, it's not a polynomial function. And whatever the higher is the leading term of the entire equation, hence we will call, for this case, this is the leading term. And n of the leading term will define the function. And the coefficient in front of the highest term will be the leading coefficient. So for example, if you have a function that is to the x to the power of 4, for example, as you can see that this has a degree of 2 and this term has a degree of 4. Which is higher? The second one, right? So the second one will be the leading term. And the degree of this function, hence, will be 4. So the degree of this is 4. Now, the leading coefficient is the coefficient of the leading term. Hence, the leading coefficient will be -1. Now, as you can see, the degree of each term is an integer. So this is a polynomial function. Looking for the degree or the leading term or the leading coefficient is really simple. All you have to do is check for the power. The highest power is the leading term. And the coefficient is what your x is multiplied to. As long as you know the rule, you will have no trouble looking for the degree or the leading coefficient or any regular coefficients here. Now, let's talk about what a constant term is. Basically, you can consider constant term to have a degree of 0. What I mean is, imagine having 2. Well, is 2 multiplied to x? No, right? But if you imagine having 2 multiplied to x to the power of 0, since this equals to 1, hence this has a degree of 0. Well, 2 basically has no x multiplied to it, right? So that is the constant term. So you can just remember that a constant term of a function has no x involved to it. Okay, now when it comes to polynomial functions, we can look for many details of the function. We can look for the zeros, we can look for the y-intercept, or x-intercepts, which are the zeros, as well as the turning points. And we can also check what the special values are by using the equation. And hence, using the equation, we can graph them. So understanding all the details, on top of that, you need to understand how to calculate for the values as well. And for most importantly, depending on the degree of the function, we actually have special names for them. Let's start off with linear functions. Now, linear function is a polynomial function with degree of 1. As you can see, the standard form of an equation for linear function is ax plus b. You see what the degree is? The degree here is 1, isn't it? It's x to the power of 1. So a linear function has a degree of 1 as well as leading coefficient of a. So what is b, guys? b is the constant. The constant value here is equal to b. And each of these values has a rule. The rule is that knowing what the values are, we can actually determine what the graph is going to look like. Okay, now starting off with our value for a. The a is what the slope of your graph for your linear function is. What is a slope? Slope is rise over run. Now, imagine having a straight line. Well, linear functions always give you a straight line. If you choose any 2 points, right? And if you measure the rise and the run between the 2 points, that will give you what the slope is. You will just have to simply get your rise and get your run and divide the rise by the run. If you know the coordinates of the 2 points, you may subtract away the 2 y values and divide it by the 2 x values, considering this as the x2 and y2 and this as the x1 and y1. Okay? So it's simply the rise of a run. Just remember the basic meaning of it. I mean, remembering the formula is important, but understanding where it comes from is more important in math. Next, the constant value b is the y-intercept, because if you think about it, what is the meaning of y-intercept? The value of x, right? I mean, the value of y when x is equal to 0. The value of x here is equal to 0, right? So technically, when you plug in 0 as x into the function, you will be getting b. Hence, b, the constant, is your y-intercept. So you know wherever you cross the y-axis, that's going to be your value for b. Okay. Well, there are other things that you must understand when it comes to linear functions, because they don't always give you a single straight line. Sometimes they give you more than one. And especially when the given two lines are perpendicular or parallel, you must understand their slope relationships. Well, I mean, you know that if two lines are parallel, then their slopes must be, well, equal to each other, right? Because if two lines are parallel, the rise and the run between the two, well, any 2 points will be equal to each other. Hence, any two parallel lines will have a same slope. But when it comes to two lines that are perpendicular, the slope has yet another, well, relationship. When two lines are perpendicular, then one of the slope has to be, okay, has to be negative reciprocal of another. Hence, if the slope for this one was, say, -2, then the slope for the other line has to be positive 1/2. Okay, you flip it and change the sign. That is the relationship between two perpendicular lines. So let's talk about slopes in general then. So what types of slopes are there? Well, technically there are 4 types of slopes. We have positive slopes, and we have negative slopes, and we have zero slope as well. Well, I told you 4 types. I'll tell you what the last type is. Well, the last type is actually having a no slope. Let's talk about positive slopes first. For any line that has a positive slope will have to rise to the right. Remember that, it's rising to the right. If the line has a negative slope, then it will be falling to the right. If a line has a zero slope, then, well, it's steady. It doesn't rise nor falls. If it has a no slope, then, well, it's vertical. Remember the difference, especially these two. I've seen, students who are confused between the two. Zero slope gives you a horizontal line, and no slope gives you a vertical line. Don't forget that. So what happens is that if you see a line that is rising to the right, then you know whatever the rest of the values are, whatever is true about the function. There's one thing that you can say with confidence is that your slope here, well, is positive, right? And here that your slope here is negative. Well, here your slope is equal to 0. So technically, when it comes to a zero slope graphs, you will be, well, given by an equation that says y equals to something. Because you see how a is equal to 0, this part just disappears to 0. So y equals to some number always gives you a line that is horizontal. And this is given by an equation that says x equals to something. Okay? So, well, it's really simple, guys. If you think about it, it means that no matter what your x is, your y will always be the same value. And this means no matter what your y's are, your x will always be the value given. Okay? All right, now, so let's talk about this simple example. It says that there is a line L that is perpendicular. Remember what we said about perpendicular lines? Well, there is only one thing that we know about perpendicular lines, right? What was that about? Well, the slope. What is so special about the slope for the perpendicular line? Well, it's that if your slope was initially m, then the perpendicular line must have a slope that is negative 1 over m, right? It's really simple. Okay, now, what about this? Well, for this one, I mean, it seems like a composition. I mean, it's a function question with plugging in f of x into g of x, right? But technically, I just wanted you to think of something. It says g of f of x, which is 2x minus 3. But if you think about what g of x is, isn't that 3? So if you think about it, this is this situation. You see how g of x, the y value, is always 3, no matter what your x is, right? So this will give you a horizontal line graph passing through the y-axis at 3, okay? And the thing is, whether you plug in 2x minus 3 as x or not, your y value, your 3, will not change, okay? So it's, this is a quite common SAT subject question for math level 2. And the thing is, students sometimes do think that, something will have to change for your 3 when f of x is plugged in, right? However, if you just think simply, it doesn't matter what your x is. It's going to be a 3 at all times. So the answer here will still be a 3, okay? So just, if you have to, having the graph, right, will actually help you understand what is going on. So just don't forget that. All right, so this is what you need to remember for linear functions. So now let's move on to degree 2 of a function, which is called as a quadratic function. And quadratic function is a very important topic. It's, there are so many things that you need to understand and memorize as well. Well, first of all, this is the standard form of a quadratic function. The degree starts with a2, so degree equals to 2, right? And c is your constant value. And for the same reason as before, when you plug in 0 as x, the only thing that is left will be c, right? So c is your constant as well as your y-intercept as well. Okay, now talk about the things that you must remember when it comes to quadratic functions. There are so many. Well, first of all, quadratic functions, you can actually find the zeros using, factorizing or using the quadratic formula as well. So anyway, what is a zero? Well, zero, as I have mentioned earlier, zeros are basically the x-intercepts. So having f of x is equal to 0, right? What values of x will satisfy these conditions? Well, that will be your zeros. Well, sometimes we call them as the roots of the function, but it's also the x-intercepts. So what are the same thing? So if you consider factorizing this in order to get the 0, right? When you factorize a function, so say you will get like x minus p, x minus q. You will get 2 factors, right, at most. And you will probably then will let this is equal to 0. Hence, you understand how x has to be equal to p or q, right? So technically, the zeros and the factors and the p and q are all related. Okay, so if you know the 0, you can also find what the equation is. So you can always go back and forth, okay, between the graph to 0, 2 factors, 2 equations, and equations to factors to zeros to the graph, okay? So just understand the correlationships between the zeros and the graphs and the equations, of course. There are other ways of getting the important part of the graph. So before we discuss further, let's just let's just talk about what a quadratic graph usually look like, and the reason why we have to understand and remember so many details when it comes to quadratic functions. Well, simply the reason why we have to memorize so many details about quadratic function is that, well, there are usually two different shapes when it comes to quadratic functions. Remember, for linear there were four: positive, negative, 0, and no slope, right? It was about slopes. However, when it comes to quadratic functions, it's a little bit more complicated than just like understanding like one simple detail. Well, first of all, you need to understand what kind of shape, it's going to be. We call them as, concavity. This is being upward, concaved, upward, and this is being downward. And, well, this is actually perfectly folded in half about this vertical line. So at x equals to some value, there is, I'll call it as h for now. When x equals to h, which will give you a vertical line, right? Will give you the line of symmetry of a quadratic function graph, which we actually, this shape actually has a name. We call them as a parabola. Okay? So parabola means like this, the U or upside down U-shaped graphs with a perfect symmetry line. And we also call the bottom or the top of the graph as the vertex. So vertex and vertex. So as you can see already, we have talked about like how this can be concaved upward or downward, and then the fact that it has a line of symmetry, right? As well as the vertex. So you see there are so many little details that you have to understand when it comes to graphs of quadratic functions, and that's why there are so many things that we need to, well, understand and remember. And on top of this, we also need to mark the zeros if it has any real zeros, and show the y-intercept as well, where, well, y-intercept is the easiest part for you to look at, I guess, because it's simply the constant value of the equation. So, okay, let's continue. So the zeros are usually really easy to look for, especially if it's factorable. But if it's not factorable, you may use the quadratic formula. You remember the quadratic formula, right? Quadratic formula gives you the value of x by using, remember, negative b plus y minus square root of b squared minus 4ac over 2a. So just know to factor and remember the formula as well, because not all equations can be factorable. Okay, now there is a direct relationship between the zeros and the coefficients of your function as well. As you can see, if you decide P and Q to be your two zeros, okay, then the negative sum of the two zeros has to equal to b over a, the coefficient of x and x squared. And the product of p and q equals to c over a, the c as the constant and a as the leading coefficient. So remember, like before I said, you need to understand the relationship between the zero and the equation and the graph. So this is one of them. Just learn the relation. Okay, let's move on to this part, completing the square. Okay, this is the equation that will tell you where the vertex is at and the line of symmetries is at. So usually your quadratic equation is given in this form. If you convert this into, well, let me rewrite this into this form. You see the difference? Instead of having something squared plus like other terms added to it or subtracted, we are having a perfect square form. Okay, so your x minus some number inside of the bracket is being squared. When you have your standard form of an equation into this form by doing this, or by actually factoring out and, making into a perfect square form, whatever the value that you get here and here actually gives you what the vertex of your equation is. And since this is the vertex, right? The x-coordinate of the vertex, that is where your line of symmetry is. So just remember, this is just another form of writing a quadratic function equation. And the reason for doing this is simply to understand what the vertex is. But however, though, this method, right, is actually used really commonly for conic section problems when things are expanded out and you have to make that into a conic, equation. You have to complete the squares. So just, understand how to do it properly. And I'll just show you some examples in a minute. All right, anyways, so let's just talk about like one thing at a time. An example about the first part of the note, the relationship between the zeros and the equation. If you are given a quadratic equation and you know that there are two zeros, -2 and +1, then what will be the missing values of the equation B and C? Remember the rule? I said remember the rule? The sum, right? The negative sum between the two zeros, right, equals to, what was that? Right there, B over A. A is the leading coefficient, and the product equals to C over A, right? So you just need to plug in the values into this rule. So what is P? What is Q? -2 and +1 are your P and Q. And what is your A? What is your B? What is your C? Well, A here equals to 1, B is B, and C is C, right? So let's, put the values in. What is the negative sum? -2 plus 1 with negative sign outside gives you +1, right? That equals to B over A, hence B. And the product, -2 times 1, gives you -2, and that equals to C over A, hence C. So there you go. These are the values for B and C. So if you just put these values back into the equation, then you will be getting your function equation as, here we go, function equation as f of x equals to x squared plus x minus 2. That will be the equation that will have two zeros, -2 and 1. Okay, so that's how we use this rule. And for second example, let's try to complete the square, guys. Let's find out what the h and k, okay, is. So just remember that you have to somehow make this into x minus h squared plus k, right? So put that into a perfect square form. So the first thing that you have to do is factor out the 2. For your x squared and x terms only though, you may leave your +1 on the outside as it is. And then, well, now consider what do you need? What do you need in order to make this into a perfect square form? What you need is, okay, what you need is half of this squared. Do you understand? Half of this squared. What is half of 3? 3/2, right? Square it. What do you get? 9 over 4. You need to add 9 over 4 in it. Okay? So when you put this in here, however, you must consider, isn't 9 over 4 something that you just made up, right? So that you can put this into a perfect square form. Hence, to even things out, you must subtract the same amount, okay? So, well, consider subtracting subtracting 9 over 4, right? As well as adding it. However, the 9 over 4 will be subtracted on the outside of the parenthesis. So when you put this on the outside, you have to multiply that by 2 first, because 2 is the common factor of the entire parenthesis, right? So technically, you will be subtracting 9 over 2. Okay, is that okay? Half the value, square it, right? And you have to even things out by subtracting the same amount. Okay, now, so what happens after that is that you will be getting then the whole thing then will turn into x, right? Minus 3 over 2 squared. If you don't trust me, expand it. Okay? If you expand it, what do you get? You get x squared minus 3x plus 9 over 4. Okay? So once you practice a few, and if you're certain that the rule is actually perfectly correct, then you know sometimes I actually skip this step. For me, what I do is I simply factor out the leading coefficient, then whatever I see as the coefficient of x, I put half of that here, right? So to cut some steps. So anyways, what is this part? That's 1 minus 9 over 2, which will give you negative 7 over 2, right? So here is your vertex form of your quadratic equation, meaning this is your a, and this will be your h, right? 3 over 2, and this will be your k. And guys, please be careful. Your h is supposed to be subtracted and k added. Hence, your h, comma, k for this will be half of 3 and 7 over 2. So that will be negative. So no negative here and yes negative here, okay? Now, this is your vertex. So we need to talk about other stuff in order to graph this. But for now, at least we know what the vertex of this equation is, okay? So remember why we are doing this and how to do this. Well, the how to part is harder, so you will have to practice like at least dozen questions before you get used to doing this. So on top of this, by the way, since this is the value for the vertex, we know that your graph will have a line of symmetry when x is equal to 3 over 2. Okay, this will be the line of symmetry. Okay, so for this quadratic function part, for this page and list, please remember this rule especially and the meaning of completed form. Okay, after you complete the square, you need to understand what it implies. It implies that the two values that you see here and there are the coordinate for the vertex of your graph. All right, let's move on to more things about quadratic functions. Well, remember, we still have to understand what determines the concavity as well, right? Actually, that part is really, really simple. In order to understand the concavity of the function, what you need to do is understand, understand what the value of the leading coefficient is. The leading coefficient tells you whether your graph should concave upward or downward, right? Positive A gives you concaved upward graph. Negative A gives you concaved downward graph. That was really simple, right? So here again, HK is the vertex. A tells you which way it will concave. And here comes the quadratic formula one more time. And axis of symmetry, the value for H, right, will always be this. And if you think about it, remember how I told you to factor out the leading coefficient first, hence divide the A, right? And I told you to use half the value of that, hence 2. Negative B over 2A is the value for your X, for the vertex, I mean. And finally, let's talk about zeros a little more. So we have already talked about that if you have two real zeros, you can actually figure out what the equation actually is, right? Given a few more details, of course. However, do we always get two real zeros? If you think about it, consider this. I'll show you. Well, consider having positive, all right? A. So it will be concaved upward, right? Sometimes your concaved upward graph will pass the x-axis twice, but sometimes it will pass it once. or sometimes it won't pass it at all. That means that if it passes the graph twice, right, then, well, the line passes twice, meaning that there are two real values of zeros. If your curve, parabola, intersect the x-axis twice, that means that you will be having two real zeros. If it passes through the x-axis, well, actually, it's kind of just like bouncing back, isn't it? That means that it's touching the x-axis only once. Hence, you only see one distinct real zero. And if the graph does not touch the x-axis at all, then you will be having no real zero. And discriminant actually can tell you how many zeros there are without, having to graph it first. Basically, when you plug in your B and C into this formula, and depending on what the values are, if the value comes out as positive, then you know without knowing the graph, right, that there are two real zeros. If it equals to 0, then 1. If it's negative, then none. So there are many things that we can determine by just looking at the simple equation. And, when it comes to functions, you must understand the relation between the function equation and the graph as well. So do not forget the details. So here we go. Discriminant, is what, something that shows how many real zeros that your quadratic function has. All right, we will continue with higher degree functions in the next lecture. Yeah, thanks for listening.